Hi everyone, thank you for joining me here today. I'm Jonathan from Drawbridge, a specialist in digital manufacturing solution. We provide solutions such as 3D modeling, 3D scanning, and 3D printing solutions in the market. Today, I'll take this opportunity to talk about the role of 3D technology in digital transformation and future of manufacturing. Now, let's begin. So how will future manufacturing compete? The manufacturing industry is an exciting field to be in. It has experienced rapid growth and evolution over the years. For example, in Industrial 1.0, we started using steam power and mechanical power to power up production in order to produce components. And Industrial 2.0 is where we started using electrical energy to power up assembly line to be able to mass produce in order to fill up the whole market. And in Industrial 3.0, that's when we started using computers to do programming and electronics to help build automation for those repetitive work in manufacturing, where it helps us to increase the productivity rate. Now we're in the forefront of Industrial 4.0, where Internet of Things or IoT focuses a lot on digitalization. This actually allows us to store and collect a lot of data, lots of data for us to analyze and base our decision on those data. So the question here is, how does 3D technology plays its part or role to achieve this Industrial 4.0 objective? Let's look at the benefits of having this 3D technology. So first thing first is 3D technology, when implemented right, it can help you to reduce waste. To give you an example here is additive manufacturing or 3D printing. So 3D printing can be used for prototyping stage without the need to mass produce. With 3D printing as well, manufacturers can print parts on demand. What this means is you reduce the need to store tooling and reduces the need to store the amount of material required to produce the components. Then in that way, it helps you to reduce the amount of waste that you create on a daily basis as well. Next is by using, for example, like 3D modeling technology right now, you can actually produce smarter. For example, like the recent development from Autodesk, generative design allows user to input in its particular data of the components they want to build. And with generative design, it's able to compute different types of design based on those input, and user is able to pick from those design based on its feasibility. You can also manage your data more efficiently because of this big data that's coming in Industrial 4.0. There are data management solutions that help you to manage this data. So for example, design work, you have a lot of data that's stored, and every time you redesign, there is a revision to it. You can use this data management solution, for example, such as Autodesk Vault, to help you to manage those data and store them in a more secure manner. You are able to also create innovation faster by using reverse engineering. Reverse engineering uses a 3D scanning tool. Here we have, for example, Preform 3D scanners that helps you to convert those actual part into CAD models for you to reproduce, or take that existing part for you to innovate on by using 3D scanning. So you can leverage on technology, all this technology for automation as well. Being able to automate certain processes in your manufacturing helps you to increase your productivity rate and also be able to put your manpower to better use, such as data analysis. So how do we leverage on technology in this? So let's talk about product design stage, right? So in the product design stage right now, in the digital manufacturing era, it has been elevated to another level. With 3D modeling technology today, you have tool that is able to provide you with designs that come with more ambitious idea. So, for example, when I shared earlier on the recent development of Autodesk, so like this generative design engine allows you to input on, for example, the size, the weight that you want, or even the dimension that you need and the material that you want on your part. to compute hundreds of different possible of design based on that input, which usually take a couple of months to even accomplish with a normal designer. With that, you don't need so many manpower or designers to come up with so many designs, but just using this engine generated design, you're able to come up with many different type of possible variation and pick one of it and produce it out. So even before you even produce, you can just simulate your design based using 3D modeling and visualize your design to life before it's even fabricated out or made into an actual part. So here I have an example, Volkswagen, who has benefited from this 3D modeling technology. Here they use Autodesk product design, whereby they apply the generative design by Autodesk on their wheel design to reduce the overall weight and rolling resistance on the tires. So what's the outcome of this? Because of them using these 3D modeling tools from Autodesk, they were able to create these new wheels at 18% lighter than their standard set. And the development time of this new product was cut down from 1.5 years usually to a matter of months from the stage, from design stage all the way to manufacturing stage. So let's play this video by Volkswagen and see how did they implement this.
Human engineering combined with artificial intelligence. Lighter, smarter products. And here is a huge potential that can revolutionize not just the products that we're providing, but also the way we work.
It's about finding ways to extend the range beyond anything that we thought possible. One way to do that is to make the vehicle as light as possible. That's where generative design comes in, using artificial intelligence to design structures that are lighter and stronger than anything we thought possible.
We have been looking for something that would really represent our company's DNA.
The goal of the Type 20 is to provide a platform for us to show really cutting-edge technology in a really emotionally impactful way.
It is the very classic Volkswagen bus, which stands for the heritage of our company, of our company's values, bringing people together on their journey, providing individual mobility and freedom.
It was amazing to see how the software worked and how quickly it worked, how just a couple inputs could get us like literally hundreds of results. It was staggering.
The generative design process lets you optimize for different manufacturing methods, like CNCing the wheels from metal or casting them from molten metal.
One of the biggest surprises for me was seeing just how much material you could remove from a conventional wheel structure.
When the final rims arrived here on site, it was kind of like Christmas morning. The whole team was excited to open the box and see how these really look. I'm really proud of the team here that we were able to put this thing together and show our vision of the future of both the company and of the automotive industry.
So you can see that how amazing it is by applying this 3D modeling technology, which is generative design, that's able to cut down their manufacturing and development time and allow them to experiment with different designs that they usually is not unable to think of. So ambitious design from using just Autodesk 3D modeling tools. So let us move forward from here. So next I want to talk about is additive technology. So additive manufacturing is the most talked about 3D technology out there. It's also one of the technology that enables manufacturers to push their product faster to the market. It has come a long way since they first emerged in 1987. Today, you might find different types of 3D printer technology out there, from FDM, SLM, SLA technology. The advantages are enormous. Not only that it helps you speed up your product to market, but also allows you to create your product based on demand. So you don't need to store enormous amount of material. Second, it also allows you to take product prototyping to another level, where you're allowed to try out different designs on the go just by using additive manufacturing, right? Next, I want to talk about is also 3D scanning. So 3D scanning is a good technology that many has implemented over the years for reverse engineering. So what happens is, for example, if you have designs or parts that were considered legacy parts, or it's no more in production, it can help you to 3D scan those. You can 3D scan those parts and recreate the CAD model again, put in your own design or innovate the design and produce it out using additive manufacturing or 3D printing as a prototype. And with that, it actually speeds up the whole development time, reducing the development time taken for you to recreate the existing design again. And by using 3D printing, it actually helps you to develop it into a prototype faster. And with the prototype that you have print out, you can use scanner again, 3D scanning to scan and compare and verify the result of your part to your CAD model. So you can use that. So for example, a company like Creaform produce our 3D scanning for reverse engineering purpose or even quality inspection purpose. So here we have this company, Lincoln Electric, which has successfully implemented additive technology and also 3D scanning. So they are a full service provider of large metal parts using in-house additive technology. The fact that they make large metal parts, it's where they cannot use conventional CMM methods to do their verification or measurements, because it's a hassle to bring the large part to CMM, and also CMM has issue trying to measure those complex surface of their metal parts. This is where the 3D scanning fits the bill, because 3D scanning allows you to scan and measure at a faster rate and also able to verify those complex surfaces. So let me play this video for you to have a look at how they do it.
First of all, it's super cool. This doesn't have to be part of it, but I think it's so cool. I love teaching people how to use the scanner and seeing the look on their face the first time they see the scan being created in the software while you're capturing it.
Lincoln Electric Additive Solutions is a full-service provider of large metal parts using Lincoln's in-house additive technology. The fact that we were going to make very large parts, measuring feet and meters, hundreds, sometimes thousands of pounds, we knew that a coordinate measurement machine was not going to cut it. So we looked at alternatives, and 3D scanning fit the bill.
We chose 3D scanning opposed to conventional measurement techniques because it allows us to get a full 3D surface model of what we just printed, and then we can take that and compare it back to the original CAD model.
A lot of times we have parts with unique features. We want to make sure those features are exactly where they need to be. So we need the 3D scans to encompass all of the complex features that we're printing and also make sure that we can verify all of those features are correct.
There are a number of benefits the Creaform Metroscan 3D provides to us. First of all, it is very fast, so we can measure our parts in a matter of minutes. Secondly, it allows us to take the measurement tool to the parts rather than the parts to the tool. Our parts are very heavy and large, so minimizing the movement of the parts is important to us.
What makes the Metroscan great is that it's a non-contact solution. We're able to scan our parts and verify dimensional quality anytime during the manufacturing process, even mid-print when the part is still too hot to touch.
The Metroscan helps our business because we can have confidence that every part that goes out the door is according to customer specifications. Also, it helps us in speed to market because it is such a fast way of measuring parts. Lincoln Electric Additive Solutions is growing, and as we expand, Creaform's Metroscan will continue to be an integral part of our manufacturing process.
So you can see that with them using the 3D scanning technology, it allows them, this 3D scanning technology from Creaform, it allows them to be able to get their product faster to the market, because the verification of the products that were produced from the additive technology can be quickly verified before sending over to the customers. This is how this 3D scanning and also the additive technology help them to move a step ahead from their competitors. So data management is so very important. So 3D technology does play a role in data management. So as we know, as company grows, so does the data that it stores. So Industry 4.0 focuses a lot on those big data and management of data. So what we can ensure here is with the right management of data, it can increase the collaboration between organization or departments because you're able to analyze this data and make decisions at a better rate. Besides that, for example, like in data management solution, like Autodesk Vault, for example, it allows a company to be able to track the changes to their design data. So for example, if you have a lot of design from 2D drawings and all the way to 3D models, or even your BIM data, for example, most of the time you have different revision, different design history. So how do you track all this together? Well, if you need to backtrack to the previous design, you can actually use Autodesk Vault, which is a data management solution, to store all your data in, where you can seamlessly connect to that server and retrieve any information you need. At the same time, if your designer decided to update a particular drawing, right, a 2D drawing, for example, you will be able to see the history and be rest assured you will be able to pick the latest revision out of it. It allows the company to be able to make decisions better in that sense. And also in terms of planning itself, you're able to plan better with the right management of data. So over here, I have a sample here, a company where they successfully implemented the Autodesk Vault, a data management solution, to their manufacturing process. So they manufacture and design lights specialized in architecture, office, and retail space. The reason why they chose to implement Autodesk Vault is because they realized that they have many different type of designs that they produce, and it's hard for them to manage all this data. And at the same time, they realize that they cannot win every contract if they cannot supply high quality BIM data to those projects. So they chose Autodesk Vault or this data management solution because it's able to provide this high quality BIM data and is able to store them in a secure manner where you can extract and exchange this information easily through one central point. Let us look at how they implement this data management solution from Autodesk.
Multoluce is ein Leuchtenhersteller mit der Spezialisierung auf
Multoluce is a lighting manufacturer specialized in architecture, office, and retail. We manufacture products that come in very many variants. For all these products, we have to provide data. For example, data for light simulation, 3D data. Our challenge now is to make the load of data available in high quality. The demand for BIM data is there. We learned that we cannot win every contract if we don't supply BIM data. We have been observing this topic for a relatively long time and have also been working with various formats, like IFC formats. After all, we chose Autodesk and Revit because the integration simply works best and the data quality is very, very high. There is a continuous process chain across all areas. Autodesk's products enable this consistent process with seamless integration, exchange and collection of data at one central point, the Autodesk Data Management System. Multoluce offers many different variations of one lamp. The procedure now is to work with Autodesk to create an automation process to generate the BIM data. We can't build 50,000 luminaries in Revit manually. That's just impossible. The question is, how can we make intelligent data available without simultaneously revealing too many secrets about the product? This is actually a big topic for us. The idea is to create a simple step file as a basic 3D file. Of course, we want to automate that process as much as possible. Actually, we are testing already a lot in Inventor. Inventor and Vault are supposed to contain all the basic data, and that's why we're going to continue our path together with Autodesk.
So you can see that with Autodesk Vault, or a data management solution, is able to allow them to seamlessly exchange and store those high quality BIM data. And right now they're looking at even going a step forward by automating those data conversion from their BIM data using Autodesk Inventor. This is how they implemented this data management solution to help them win contracts and also to manage their data better. So 3D technology also allows you to automate your work that are mainly repetitive and allow you to put your manpower to better use. So let me show you an example here where automation can be implemented. For example, you can actually automate your 3D design process by using iLogic by Inventor. So iLogic is basically a tool that allows you to program certain 3D design processes that could be repetitive or complex. I have an example here whereby this lamp here, whereby iLogic is used to come up with different variation for different design. So you can see that you have different designs and variation that can be fit into assembly. If you have to do it in a normal manual procedure, it might take you a long time for you to fit in, let's say, 10 different designs to come out with different variation. And for example, if you will need to go for a demo or probably to show it to your customer, with iLogic, you're able to put in this different design and variation, and the user can easily exchange all these designs and variations through a click of a button without the need to go through the hassle of assembling each and every part again and again. Next is also on this 3D scanning. So 3D scanning can actually be used to automate your inspection process. So you can automate your inspection process using 3D scanning, and it's usually preferred over conventional CMM equipment these days. The reason is because scanning actually provides a faster measurement method, and also it's able to measure those complex surface or freeform surfaces that most conventional CMM is unable to measure. So we have this company called Walter Automobile Technique, where they have successfully implemented a fully automated measurement system using 3D scanning and on their tubular space frames for their all-electric Mini Cooper frame. Why did they turn over to automated 3D scanning? The reason is because they had a problem using conventional CMM that only can complete required measurement at about an hour and a half. And with the implementation of automated 3D scanning solution from Crayform, they were able to achieve for the first time the required measurements at 15 minutes. This is an improvement over 6 times of their usual speed and allows them to increase their productivity rate.
We are the Walter Automotive GmbH, and Walter started 25 years ago. Today we are talking about 150 to 200 people. We are a supplier for big OEMs in the automotive industry and the motorcycle industry. We are doing chassis parts, we are doing welding parts, we are doing welding groups. We have a high automated level in the machinery park, and we need that to cover the demand of the customer, because the customer is producing an e-car, and that e-car is increasing. We have a high frequent output of that line, and we are measuring hundreds of measure points on that frame to cover 100% quality. It's a stable system, it works very good and it works sustainable. And that measurement system gives us a relief, because we could never do it without an automatization.
first steps of the E-frame is to weld the parts, and then it goes to the CNC machining. The next step is the HTV galvanization, and then it goes to the assembly line. And at the end of the line we have our 100% proof system with the 3D automatic creaform system. Our requirements to a measurement system for this E-frame was that we need fast results and have a good turnback for every frame. The problem is of the 3D coordinate measurement system that it's go very slow. We need here 1 hour and 30 minutes. And with the creaform system, we are at the first time with the 50 minutes. Now we are at 8 minutes. The installation of the robot system and the creaform goes very fast. It was in 2 weeks. It is possible to do trainees at 1 day, and they can do this work at the creaform.
We see that there's a quite huge market. There are not many welders anymore, many welders in Germany on that high automated level. We have a lot more capacities to automate our processes, so we are in a good start position to grow regarding 4.0 or Internet of Things and so on, to be able to make the next step.
In the future, we think a 3D system in the automotive industry is a must-have. It's very easy, very simple, very good to work. The process stability is there. In one word, I love it. I hope for another creaform system in our company for new projects.
So you can see over here with the implementation of this automated 3D scanning solution, by creaform, they were able to overcome the bottleneck of achieving higher productivity rate in, due to those demand for electric cars. So over here, you can conclude that 3D technology does play its role in achieving this Industry 4.0. In fact, it does provide a lot of benefits to a lot of manufacturers out there, as you can see from some of the examples I shared earlier on. So a little bit on Drawbridge. So Drawbridge began in 2002, and we have gone a long way since. We specialize in providing these 3D solutions that you have seen earlier on. We are more than happy to see how we can help you. Please feel free to drop by our virtual booth, and we can set up a discussion to look further in how we can help you in certain areas. Like ourselves, we strive to be your preferred technology partner, and I look forward to seeing you in the virtual Metal Tech. So here, I would like to end my tech talk here, and I'll see all of you, and thank you for spending this time with me.